During the Cold War, the superpowers were obsessed with building bigger missiles, spying from space, and planning for nuclear conflict. Yet behind the headlines of these spectacular technologies, a far less glamorous but equally critical challenge was unfolding on the ground, hiding military assets from the increasingly sophisticated eyes in the sky. Reconnaissance aircraft, high-flying jets, and the first generation of spy satellites were suddenly able to see things that had once been nearly invisible. Bases, convoys, and supply installations that had relied on simple camouflage were now being revealed with unprecedented clarity. Traditional camouflage methods, paint, brush, burlap, or netting were suddenly inadequate. What had successfully hidden tanks and encampments during World War II was no match for cameras that could detect infrared heat or sensors sensitive to precise colors. Vehicles perfectly painted to match their environment were still exposed because their geometric shapes, sharp edges, and unnatural shadows betrayed them from above. The Cold War revealed a hard truth. Hiding effectively was no longer a matter of artistry. It had become a problem of science and engineering. This problem forced engineers and researchers into a new kind of arms race, one that wasn't fought with missiles or tanks, but with physics, optics, thermal signatures, and material science. The task was simple in concept, but difficult in execution. Design camouflage that worked not only for the human eye, but against the full range of sensors that could detect heat, shape, or radar reflection. It was this race that ultimately gave birth to a revolutionary innovation that still influences modern military and survival practices today: multispectral camouflage. Multispectral camouflage marked a fundamental shift in the way concealment was approached. Instead of focusing on blending visually with the environment, scientists began thinking about controlling how objects appeared across multiple wavelengths of detection. Visible light, infrared radiation, and even radar signals had to be considered simultaneously. Camouflage was no longer about paint or patterns. It became about engineering materials that could absorb, reflect, and scatter energy in ways that confused and misled sophisticated sensors. This approach allowed objects to effectively disappear from planes, satellites, and early electronic surveillance systems. By the 1950s, the shortcomings of traditional camouflage were painfully clear. Jet aircraft were flying faster and higher than ever, photographing vast stretches of land, and programs like the U-2 reconnaissance flights made detection even more precise. Militaries realized that even a perfectly camouflaged vehicle would still stand out due to its edges and shadows. Infrared cameras made the problem worse. Engines, metal surfaces, and even freshly disturbed soil emitted heat that revealed their presence. Simply matching colors wasn't enough. Concealment now had to account for heat signatures, outline disruption, and radar scattering simultaneously. The breakthrough came when engineers stopped trying to match the environment visually and instead focused on matching signatures. Layers of materials were developed, each designed to manipulate a different type of detection. A single sheet of fabric could reflect visible light in a woodland pattern while absorbing infrared to mask heat. Another layer might scatter radar waves, preventing electronic detection from registering a clean signal. The genius of multispectral camouflage was not just the materials themselves, but the principle behind them: target multiple weaknesses at once. This turned camouflage into a precise scientific discipline rather than an art form. Both NATO and Warsaw Pact forces, along with later independent innovators, built on this principle. By controlling thermal output, disrupting radar echoes, breaking outlines, and manipulating how light interacted with equipment, They created materials that could hide vehicles, equipment, and personnel from nearly every type of sensor available at the time. Modern ghillie suits, mobile netting, and thermal masking tarps all owe their existence to these Cold War innovations. Even today, anti-drone and infrared blocking solutions follow the same core principles. The influence of multispectral camouflage extends far beyond military operations. Many survivalists, outdoor engineers, and bushcraft enthusiasts unknowingly apply these lessons when constructing shelters, designing clothing, or managing gear in the wilderness. Layering fabrics to create an air gap, breaking up patterns with irregular shapes and textures, and wrapping metal objects to prevent sudden temperature spikes are all practical ways to reduce detection. These methods mirror the strategies developed for Cold War radar and infrared protection, demonstrating that the principles of multispectral camouflage have applications in everyday survival and outdoor engineering. Modern militaries continue to rely heavily on multispectral principles. Even with the introduction of drones, satellites, and AI-enhanced imaging, the foundation remains the same. Manipulate visible, infrared, and radar signatures simultaneously. Tanks use thermal diffusing paints, developed from Cold War prototypes. Anti-drone tarps and shelters employ layers that control heat and reflectivity. And adaptive camouflage technologies that can electronically change patterns still build on the layered, multi-wavelength strategies first developed decades ago. The battlefield, it turns out, is no longer purely physical. It exists across a spectrum of energy. Those who can control their signature across that spectrum gain a decisive advantage. For enthusiasts, historians, and engineers, understanding multispectral camouflage has both practical and educational value. Restoration of military vehicles, gear design for wilderness survival, and even the study of historical surveillance can all benefit from knowledge of how light, heat, and radar interact with surfaces. Observing archival footage or examining original materials reveals exactly how these techniques were first tested and refined. What began as a Cold War necessity has become a guiding principle for staying unseen in a world increasingly full of sensors. Multispectral camouflage was not merely a curiosity of Cold War innovation, it was a turning point in how humans approach concealment. By transforming hiding into a science, it changed the rules of survival and warfare. Today, every soldier, engineer, and survivalist who thinks about controlling their visibility owes a debt to those early experiments. In a world where sensors can detect more than the eye can see, mastering how you are perceived, not perceived, has never been more critical.